Graphing review, well, in theory, this is all review, but I'm going to assume you've forgotten most of it. So in Math 10, you learned that equations of the form y equals mx plus b, which you also called slope-intercept form, are lines. Lines. First, we defined slope. What letter, what variable did we use for slope? Sally, why not S? Because not all math was done by English-speaking people, you bigots. Other countries do math too, okay? Broaden your worldview. The M, I believe it comes from a French word for mountain, slope, okay? So I've told you already that I tend to abbreviate, yes? So I'm going to use the letter lowercase m for slope. I'm not going to write the word slope. So M equals, and you learned last year, slope is defined as what over what? Rise over run. I left a letter out on purpose. My high school teacher used to always spell it R-Y-S-E to remind us that the rise was the wise. It's clever. You don't have to, but I'll throw that at you. About 10 years ago, I had a student named Henry, one of my top students ever. Got 100% with me in Math 12, got 100% in my calculus class, and he was going into Physics 12. He was going into the provincial exam with 100%. And on the Physics 12, I know there's no provincials now, but there was back then. On the Physics 12 provincial exam, the very last written question was always to interpret a graph. You had to find the slope and do something with it. And he came down from his exam, and we were comparing answers. I said, Henry, oh, good, you got number 1 right. Henry, oh, you got number 2 right. Henry, I got the same thing as you, number 3. We got to the last question. It was number 6. It was the graphing question. Henry, my answer is 0.25. Your answer is 4. And I realized 4 is the reciprocal of 0.25. I said, Henry, you went run over rise for slope. I've never seen a kid turn that pale, because this was a kid who never made mistakes. And that was, I don't say this very often, a dumb mistake. It's the only mark he lost. He didn't get perfect. Oh, he was a little grumpy. So rise is the wise, is the vertical, rise over run. You also learn another way to write it is triangle y over triangle x, although we don't say triangle. What do we call that? Because it's a Greek letter and we want to sound nerdily cool. Okay, delta. I will say delta because high nerd factor. But what does the delta symbol mean? It's an abbreviation for an English phrase. No, he didn't. Change in, right? I gotta be fussy. 2 words. Change in. I think he just said change. So change in. You also are given this thing here, y2 minus y1 over x2 minus x1. We'll hardly use that equation. Well, we will technically, but we'll do it right from the graph by going rise over run. So we're not going to need to memorize that equation, although I think I did put it on your formula sheet. On your test is probably going to be not the end of next week, but the week after. It's going to be a quest, half quiz, half test. I am going to give you a question very, very similar to this next one right here. I'm going to give you a grid, and I'm going to give you 3 or 4 or 5 lines, and I'm going to say graph them all. That's my way of, oh, you know what? Jordan's had me before. Conlon's had me before. I like this question. I like this question. I like this question. Jordan, why would I say that? Did you hear me say it's going to be on the test? Or you're the kind of student that tends to notice when a teacher emphasizes certain things? That's good studying. Okay. So, first question, and this is so obvious, often they don't teach it in grade 10. How can I glance at every one of these and tell you instantly they're all lines and not curves? And they are all lines and not curves. There's an easy trick where if you see an equation, you can tell ahead of time, line or curve. And this year in grade 11, you will be graphing curves, so it's worth having in your back pocket. Does anyone know it? Yeah.
Square.
Even more, he said, if it's squared, even more generic. If there's weird stuff on the x or the y, exponents, square roots, logs, sine, cosine, any weird stuff, it's a curve. If it's just a y and an x with no weird stuff, it's a line. Okay? So I glanced at all these really quickly. Do you guys see any weird exponents on them or anything like that? They're lines. That helps. Is the y by itself in equation 1? I'm going to ask the same question. I'm just going to phrase it differently. Is equation 1 in slope-intercept form? Yeah. I mean, that's really what I'm asking. Okay. What's the y-intercept? By the way, although we say slope-intercept form, Aaron, we actually graph intercept then slope. So we should almost call it intercept-slope form just so that it matches the same order. Hey, what's the y-intercept of this equation here?
-4.
All of us, let's put a dot at -4. On the y-axis, so not anywhere. The y-intercept is called the y-intercept because it intercepts the y-axis. What's the slope of this particular line? Asia, what? I want you to say it again, not to make fun of you. Say it again.
2/3.
Again.
2/3.
One more time. I'm pointing something out. This is important. Say the same thing.
2/3.
Do you notice she's saying 2/3? The fact that you're saying over 3 tells you you're going to count over 3 because kids get mixed up. Which do I count, up or down? It's up to over 3. It's not up 3/2. It's built into how we say it in English, which I kind of like. How do I know it's up and not down? Yeah.
Because it's not
Negative, which actually makes kind of sense when they show you that one in Math 10. It's kind of nice. Oh, negative downhill? That works for me. It's not like weird. Okay, so from the y-intercept up to over 3, up to over 3, up to over 3. It's built into how I say it in English. Don't know if you ever noticed that, but it helps. Then I go back to down 3 to extend it. And then I'm going to say use a straight edge, use a ruler, no freehanding. Okay, here we go. Yeah, tongue helps. And you know what? Since we're graphing 5 lines on one grid, how about I put a little 1 next to that and call it line 1? I'll try changing colors for each line. Most of you can't do that, but you know what? It'll work just putting a number next to it too. I'll figure it out. You okay with that? In theory, none of that was new. In reality, we're probably brushing some serious cobwebs off of your brain right now. I'll do line 2 in red. Line number 2. How do I know it's a line? No exponents, no weird stuff. Is the y by itself?
Yes.
I'm going to ask you the same question. I'm just going to phrase it differently. Is it in slope-intercept form? Yes. What's the y-intercept of line number 2? Positive 5. Put a dot right there. What's the slope of line number 2? Okay, so you have reached the stage where you all know that any number is technically over 1 if it's by itself. Good. Negative means count how? Down, but still always over 1. Always count to the right, but up or down. Okay, down 2 over 1. Down 2 over 1. Down 2 over 1. Good. That line 2. Is that okay, Kennedy? Yep. Okay. The third one. How do I know that it's a line? No weird stuff. Is the y, now I know it looks weird, relax. Is the y by itself? Yes. Is it in slope-intercept form then? Yes. What's the y-intercept here?
0.
Okay, so that's the question we're going to ask. I'm going to argue that this is really this. Isn't it? I'm not missing a y-intercept, I'm missing an x. Yes? So if you see that in your head, 'cause I will never write a 0x again. That's a waste of time. But that's really what that equation is. So let me ask you again, because I had a bunch of you telling me that the y-intercept was 0. What's the y-intercept? -8. What's the slope? Don't change anything. The slope here was the number in front of the x, the coefficient. The slope here was the number in front of the x, the coefficient. What's the slope? I'm telling you, that's why I said, is the y by itself? This is in slope-intercept form. It is. What's the slope? What does the slope of 0 look like?
Nothing.
Straight line? All lines are straight, Captain Obvious. More specific. A horizontal line. Okay? By the way, I was totally, kids always say straight line, and I'm ready with that dumb punchline right away. Horizontal line. Yes? So, that's going to be a horizontal line going through -8. Okay, I can draw that. This. Oh, need the ink. By the way I remember slope of 0 versus undefined slope, I always imagine a skier. If I'm a skier and I'm on a horizontal slope and I stay tucked if I'm not using my poles, how fast will I be going? 0. Yes? What if I'm a skier and I'm on a vertical slope? I'm going to become undefined. To die. So undefined slope, skier dies. 0 slope, skier doesn't go anywhere. Works for me, whatever works for you, but that's how my brain does it. Number 4. How do I know it's a line? No squareds. Is the y by itself? Then it's in slope-intercept form. What's the y-intercept of number 4? Yeah, okay. There we go. That's where there's no constant term. That's a y-intercept of 0. Because technically it's this. But Jordan, I'm not writing that again. I tend to abbreviate. And that's extra writing. What's the slope?
-1 over 2.
-1 over 2. Negative down. 1 over 2. Down. 1 over 2. I can do this. Mr. Dewick, what page? Are you going to be fussy on like arrows and... well, first of all, this here page is not physics. In physics, all of our graphs will be from real data, which means you'll be able to decide by using your imagination, does this graph continue or not? Let me give you an example. If we're graphing mass in kilograms and you extend to negative, can you have a mass of -3 kilograms? Does that even make sense? I'll take marks off for that. Don't extend there. Mass doesn't go that way. Okay? But it'll be pretty obvious. You'll go, oh, the smallest mass I can have is 0. I better stop at 0. So, will I be fussy? Not in the way you think I'm going to be fussy. I'm going to be fussy, Aaron, in the way, like matching the data. It's got to make sense in our universe. Last one. How do I know, glancing at question 5, that it's a line and not a curve? No weird stuff. Okay? Who's grade 11 this year? Who are my grade 12s? So you guys did the parabola and all that last year, yes?
I didn't take that one.
You didn't take math 11? Oh, you will this year. Okay. So anyways, grade 11s, all of you, you'll spend a whole bunch of time looking at one very special curve called a parabola. It's really cool. But then you'll learn what you learn with the parabola in math 12, you can generalize to any curve. Is the y by itself in example 5? No. Then we need to get it by itself. How? Oh, I forgot to put a little number 4 next to that one. I forgot to put a little number 3 next to that one. Okay. How? Witchcraft? Magic? Use the force? How? How do I get the y by itself? Yeah. Okay. If I want it to be general, I would say if we're trying to get the y by itself, we do the opposite of everything we see. And if you haven't noticed, it's actually reverse bedmass. In bedmass, when you're calculating, you go multiplication, division first, and then you do addition, subtraction. When you're trying to isolate something, you do addition, subtraction first. Then you do your multiplication, division. So you ready? I see a 2x being added. Isn't it being subtracted? No. The 3y is being subtracted, but in front of the 2x, there's an invisible positive sign. Can you imagine it there? So you're right, Sally, minus 2x from both sides. The negative 3y drops down like a domino. The equal sign drops down like a domino. And then on the other side, I have 9 minus 2x. No, I don't. I don't like that. I'm going to write it as minus 2x, because that's where we see the x normally. And then I'm going to drop the 9 down. Is that 9 originally positive or negative? Positive. I better put a plus sign there. That's where that plus sign comes from. It's the fact that the 9 is positive. Have I got the y by itself yet? Not quite. How do I get the y by itself? Y divide by negative 3. What's the negative 3 doing to the y? Adding, subtracting, multiplying, or dividing? Do the opposite. That's the rule for isolating a variable. If you're not sure what to do the opposite of what's being done to the variable. So I would go divide by negative 3, divide by negative 3, divide by negative 3. I had to kind of smoosh it in, but you can do that with yours. And here's what I get, Kennedy. The negative 3's cancel here. I get a y equals. I have a negative 2 divided by a negative 3. First of all, what's a negative divided by a negative?
Positive.
Are you positive? Okay. So I end up with just a 2 and a 3. The x is tacked on. And then I have a positive 9 divided by a negative 3. What's that?
Negative 3.
Let's start over. Is the y by itself?
Yep.
I'm going to ask you the same question. I'm just going to phrase it differently. Is this in slope-intercept form?
Yes.
And now hopefully we become somewhat repetitive. What's the y-intercept here? 1, 2, negative 3. What's the slope here? Which means up 2 over 3. Up 2 over... In fact, you know what? Line 5 ends up being parallel to line 1, which doesn't surprise me because they have the same slope. And in Math 10, you learned parallel lines have the same slope. Yes, the tongue helps. Here we go. Line 5. Okay. Now, that there is general math, Math 10, but I gotta be honest, Conlon, usually in physics, we're gonna be graphing in quadrant 1 here. Almost always we'll be graphing positive values and positive values, for what it's worth. Is that okay, Sarah? And now we're gonna talk specifically about science-y graphs. These following rules are rules that I will insist upon in your homework, or on a quiz, or on a test. Why did I emphasize the word test, do you think? It's going to be on there? I didn't say that, but let me pick it. Okay. Ready? This is what every science physics-y graph has to have. Number 1, you have to draw and label the x and y axis. And by label, I mean what it is, distance, comma, which letter you're going to use for it, usually the first letter, d, comma, and then the units, meters. Time, t, seconds. Momentum, comma, p. Why is p momentum? You'll learn why later in kilogram meters per second. If I see a graph turned in and you didn't label your axes, I'm taking marks off. Okay? The second thing you have to have is a scale. You have to, on your graph, number the x and y axis so I know what you're going up by. If I see dots and no numbers, I'm taking marks off. The third thing you have to do is you have to give your graph a title. If I get a graph and no title, I'm taking marks off. Now, a title doesn't have to be To Kill a Mockingbird. No, I don't mean that kind of a title. The standard title is whatever's on the y-axis versus whatever's on the x-axis. Velocity versus time. Momentum versus impulse. Force versus acceleration. Whatever. Turn the page. You with me? You looked like you were looking around going, where am I? In my room. This is your happy place. Then and only then will you plot the points. McKenna, when you plot the points, I wrote here, if we have a measurement with some amount of error, you know what? I'm not going to do error bars this year, so if you want to, you can just go, but you will still have to plot the points. If your data points look like this, and it seems to kind of be in a line-ish thing, then you'll draw what we call a line of best fit with a ruler. Don't write that down. Let me erase all that. But don't go freehand. You're going to lay your ruler down. You're going to go through as many points as you can, and then the ones that you can't go through, you'll try and have the same number above the ruler as below the ruler to kind of split the difference. There is a mathematical way to get there called least linear regression analysis or least squares analysis. You need a graphing calculator or a stats calculator. Forget it. We're just going to freehand, and all of our answers, Lexi, will be close. Then you're going to find the slope of your best fit line. How? You're going to pick 2 points. You're going to find the rise and the run, the delta y and the delta x, and find the slope. Note, please show me these calculations somewhere, either on the graph or beneath the graph, but show me how you found the slope. Use appropriate units for slope. You can also scribble out this one. We're not going to worry about sig figs. Then, you're going to find an equation. Your equation is going to be y equals mx plus b, except instead of using the letter y, use what letter you put on the y-axis. And instead of using the letter x, use what letter you put on the x-axis. Say, what? We're going to practice this in a second. A little comic for you. The guy is talking to the girl. He says, I think we should give it another shot. The girl says we should break up and I can prove it. She gives him a graph. Our relationship. Guy says, huh. Guy says, maybe you're right. She says, I knew data would convince you. He says, no, I think I can do better than someone who doesn't label her axes. Label your axis. Okay? So here's an example. Let's see if I can get this all on one page. I think I can. If I do that, one more up. Okay. We have some data. We're graphing time versus velocity. I think I said it was of a little car. Oh, I didn't even tell you what it was. It's a toy car I took this from. Okay? We're going to walk through this one together. What was the first thing I said you had to do? What was step 1? Go check, please. Don't just sit there. What was step 1?
Draw and label.
Label. Time, comma, what would be a good letter to use for time? T in seconds. And on the y-axis is going to be velocity, comma, v in meters per second. Okay? I didn't actually draw the axes because I think I kind of did that for you with the graph paper. It stops. So we'll use the edges for our axis. Otherwise, you draw those in too with a ruler. Well, step 2. This goes faster if you call it out. What was step 2? Scale. Oh, okay. Raven, what's the... Actually, before I even do that, count how many squares I have to play with, all of you guys. How many squares horizontally do I have to play with? This is how you figure out a good scale. 24? Okay. What's the biggest x value, the biggest time value that I have to deal with? 10. What would be a good scale if I have 24 squares to play with that uses as much of that up and would be easy to graph 10 things? Go up by 2s. Okay? If you went up by 1s, and so your graph only took up this much room, I would take marks off. I gave you paper so you can make a big graph. So you want to try and use as much of the graph paper as possible. So on the x-axis, we're going to go up by 2s. Hey, let's label that right now. There's 0, 1, 2, 3. Okay. Lexi, we also need to pick a vertical scale. How many squares do I have to play with vertically? Is it also 24? Yeah. By the way, usually that won't be the case because most graph paper is rectangular. Usually you'll have more room vertically. So the scales don't have to match. 24, what's the biggest y value I have to fit on here? Can I go up by 2s this time? Guess I'm going to go up by 1s. Except, look up. Don't write this down. Look up. Don't write this down. Aaron, I could go... I find it gets really, really crowded, so I'm going to go up by 1s, but I'm only going to label every other square. I'm going to go skip 2, skip 4, skip 6. In other words, you can write this down. I'm going to go skip the first square, 2, skip 4. So I'm still, each square is worth 1, but I'm only labeling every other one so it doesn't get so cluttered. Skip, 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 skip. So that's the math of how I pick a good scale. I figure out how many squares I have to work with, and then I say, okay, what's a good scale so I can fit as big a line in as possible? It's tough to explain how to do that in English, but I think you guys picked up on it. All right, now we graph. First point is 2, 5.3. I can graph the 2 pretty easily. The 5.3, I'm kind of eyeballing a little less than halfway between 5 and 6-ish. I said that graphs were great, Braden, for visual patterns. They suck for getting decimal data. It's a limitation. Next one is 4, 7.8. So 4 over 7.8, a little below 8. About there-ish, kind of, sort of? Ish? Yes? 4 over, there's 8. There's 4 over, there's 8, there's 7.8. 6 over, 10.4 is going to be kind of right, sort of right around, let's do that with a pen. 10.4, about there-ish, ish. Meaning, what's the next point? Just read it to 8, comma. Thank you. With less. Yeah, you're right. Ready? 8, 12.8. 8, 12.8. Going to be a little below 13. Yes, right about there. Ish. Hey, it does look like it's kind of sort of forming a line. Looks linear. It's because I cooked the data. Bryce, what's the last point?
10 seconds in.
10 over, 15 up. This one I can get bang on. Right there. And now you're going to take your ruler. By the way, does it look like this line goes through 0, 0? I don't think so. So you're going to take your ruler, carefully lay it down, You're going to draw a line of best fit that goes through as many points as possible and hits the y-axis. Mine kind of, I think, looks about like that. And this is where now, Asia, all of our graphs might look different because it's all in how you held your ruler, how you tilted it. So for the rest of this lesson, your answers will be close to my answers, but not bang on. As a basic example, Raven, it looks like my y-intercept is about 3.1. Jordan, yours might be 2.9. Kennedy, yours might be 3 bang on. Oh, okay. I would give full marks for all of those. We're going to find the slope in just a second, and I'll take a wide range of slopes because you might have, Jordan, had your ruler tilted like this, and Kennedy had hers tilted like this, and Raven had it tilted like, but it still works. As long as you're close, I'm fine. Okay? What we want to do now is find the slope. Okay. Oh, sorry. Part A says find the y-intercept. What does it mean? Actually, before we do that, continuing on with our steps, it's step 6, find the slope, and then find the equation. Okay. Now, how do we find the slope? This is where all of you are going to be different from me. I'm going to look at my line, and I'm going to try and find 2 points where my graph goes through the grid. In other words, Jordan, I am not going to pick right there. That would be a dumb point to pick because it's hanging in midair. I'm not going to pick right there. That'd be a silly point to pick because it's hanging in midair. For me, I'm going to pick that one and that one. Those look pretty good. Now try and make them far apart. So on your graph, try and find 2 points where your graph goes through the grid. The fancy word for that page is lattice points, L-A-T-T-I-C-E. Try and find 2 lattice points. So for me, mine are going to be right here and right here. Yours might be different. That's fine. When I mark these on a test, Mackenzie, I accept a big range of values. Sorry, a fair range of values, not a massive range of values. Slope is what over what? So I asked you somewhere, show me your calculations. Usually I'll just do it right on the graph. So I'm going to go like this. M equals. Now, here's what works best for me. Look up for a second. Don't count squares. I find it way easier with my pencil or my ruler, don't draw this, to go like that and like that. Because now I can say, how high do I go? How high is it? How high is it? 14? What's the lowest point? What's the rise? 14 minus 9. I think that's easier. Counting squares, too often you'll miss a square because it's tough to count on graph paper. So I tend to go across, subtract. By the way, really what I'm doing is I'm calculating delta y using y2 minus y1, but I'm doing it without having to memorize a stupid formula. Zip, zip, rise. So my rise is 9. Can you find your rise, please? And I'm going to erase these. I don't want to muck up my graph. Over.
Rise can be a pretty small number, right?
Yeah, but I said try and pick points that are fairly far apart. I won't take marks up. But because what you're trying to do is, if you're far apart, you're averaging out any ruler wiggles. I do the same thing with the run. I go, for me, I'm at 9, and I'm, halfway between 1 and 2. What's halfway between 1 and 2?
1.5.
So my run is 9 take away 1.5, which I probably could have done in my head, but you can use a calculator if you need to. My run is 7.5. Whatever yours is, I don't know. And the reason I do it that way is every year, Mackenzie, I have some kids that go like this. Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, 15 squares. The run's 15. But each square isn't worth 1. You know what, Daniel? If I just drop down to the axes where my scale is, I can eliminate that oops mistake by just doing some basic subtraction. And it's almost always pretty easy subtraction. In math, we tend to leave that as a fraction. In physics, we decimalize it. So whatever you got, me, when I go 9 divided by 7.5, I get 1.2. If you get a longer decimal, hey, how about to 3 sig figs? So 1 point something something. Jordan, what'd you get for your slope? As a decimal, please. I'd take that. I'd give you full marks.
Just the right
1.23 is good. Jaden, what'd you get for your slope?
1.25.
I'd give you full marks. I'd give you full marks. Connor, what'd you get for your slope?
1.25.
I'd give you full marks. Now, if you told me, if Josh told me he got a slope of 7, no. In fact, honestly, I wouldn't take anything. 1.9, I'd probably say probably not. I'd probably take anything between probably 0.9 and 1.5-ish. Okay? So I'll take a wide range of values. So my slope, 1.2. Okay? I just divided the numbers, 9 divided by 1.5. So divide your rise divided by your run. Okay? Didn't say pack up yet. Still 2 minutes left.
I just put my calculator.
I don't know, you might need it.
Ooh.
Okay? We'll pick up with this when I see you on Tuesday. Your homework is get caught up on all the other stuff, okay?